The empirical rule is not so much a rule as a practice. And in fact, it's kind of an oxymoron in the sense that empirical is something that is done by experience, something that cannot be objectively known but is much more subjectively known. So we have empirical, by experience. They have come up with this rule, which is a little bit of an oxymoron to have a rule that is because you know that it is. It's kind of a strange thing. But the numbers that you need to remember with the empirical rule are 68, 95, 99.7. What it means is that 68% of the data should be within plus or minus 1 standard deviation from the mean. 95% should be within plus or minus 2 standard deviations from the mean. And then finally, 99.7% would be 99.7% or plus or minus 3 standard deviations from the mean. Now, this is the question of how usual, how reasonable is our data. And in this case, we're going to put our data right on this chart. We're going to take our data and put them on the number line. Now, if we will remember correctly, we start with 62. So I'm going to put an X approximately where 62 would be. Then 45, then 81, 67, 63 would be in this box, 65 would be in that box, 78 would be in this box, 71 would be in this box, 42 would be in this box, 65, and 61. Now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Everybody has to be represented. What I mean by the box is between here and here, you would put anything between 40 and 52. Between here and here, anything between 52 and 64. Between here and here, anything 64 to 76. You'll notice, if you'll remember, our mode was 65, and it would fall in this highest bar. What we're in essence doing is making a bit of a histogram that corresponds to how many pieces of data are in each group. You'll notice we're starting to get, even with just 11 pieces of data, a sense of that bell curve, where it is balanced somewhere, most in the middle, but a few on each end. And that's what we're getting here. Now, remember our empirical rule. We expected 68% to fall within plus or minus 1 standard deviation. So if I have plus or minus 1 standard deviation, that is from here to here. So I go the middle plus the 12, the middle minus the 12. And I come up with 1, 2, 3, 4, 5, 6, 7. So in the plus or minus 1 standard deviation, I come up with 7 out of 11. In plus or minus 2 standard deviations, I come up with 11 out of 11. Now, obviously 7 out of 11, we can ballpark it, but if we divide it out, I come up with 64%. By the way, when I made this data, my data just came as a guess. I just threw a bunch of numbers on a page. There is no real set reason for why this data is what it is. So the fact that we're even anywhere close is a little bit amazing. For standard deviation, we come up with 100%. And that's true. You say, well, that's high. Whereas we should have been expecting 68%, we got 64. And where we were expecting 95, we got 100. But think about it. Let's assume one of these numbers, instead of being 42, was 39. If we move one piece of that data, that is 1/11, 1 divided by 11, each one of our pieces of data is worth 9%. So had any one of these values been outside, that would have moved 9% out of the middle and out to the outside. At 42, we were really close to being out of the data. So this empirical rule does show up over and over and over again. And that's one of the things that we need to be wary of when we're looking at this. So this graphical representation also tells you the spread of the data, telling you most of the data is indeed clumped around the average with these values out here. What this didn't show you as well is that these values in this box are not up near 52. They're actually way down here near the bottom. And these data pieces up here are actually closer to the 76 than they are the 88. So this one is not as descriptive, but that's because we're only using 11 pieces of data. At only 11 pieces of data, there's only so much fine work that we can expect to achieve. I'm going to do one more example of an empirical rule and creating this type of chart for you. The final example we're going to do, we're going to take those 2014 Denver Broncos that we worked on in the previous sets of examples. And what I've done is I've taken them and put them into the calculator. And dumped them in as a list. I've gone and done all the calculations on it. So calculate one variable stats on second list L2 and come up with some values here. Now, out of all of those football players, I have an average of 233.79, which will approximate to 234. I have a standard deviation of 45.79, which we're going to approximate to 46. Now, using that information, we're going to make an empirical rule chart. And in the middle, of course, is 234. So I have 234 plus 46, 280, plus 46, 326, plus another 46, 372. Again, through the magic of television, I've gone ahead and set up our chart. Taken our average, add 46, add 46, add 46, minus 46, minus 46, minus 46, and now what remains is to put our guys, our list of guys, on this chart. So I'll do that now. By simply going through and saying 200, he would go in this pot. 224, he'd go in this pot again. 274, this pot. 192, this pot. 215, this pot. 305, that pot. 195, etc. All the way down the list. Here's what I come up with. Now, if any of you remember our previous discussion of charts, you should see that we may have a potential problem with our data. Our potential problem with this data seems that we might have two modes going. That or everybody whose name go from A to F happens to be a receiver and or some sort of water boy on the Denver Broncos. So, what we end up with is this chart right here. Now, within plus or minus 1 standard deviation, we expect to see 68%. We end up with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 out of 19. And that would leave, between plus or minus 2 standard deviations, 19 out of 19. Now, obviously, this equals 100% when we were looking for 95%. 14 out of 19 is 73.7%. 73.7% or 74. So unlike last time where we were a little shy of our 68, here we're a little over on our 68. But again, we're looking for 68, 95, 99.7. This is something that was developed through experience. This is something that is a raw anticipation. It's not something that's a hard and fast rule. And again, with only 19 players, it's quite easy for things to go one way or the other. If I move one person over here, one person is approximately, 1 out of 19 is approximately 5%. That would move this to the perfect number, and that would still be a little heavy. So it all depends on which way you want to look at things. Unfortunately, when we look at this graph, we do need to examine our shape. We may very well have something going a bit bimodal, which if we look at football teams does make sense because the guys are in a particular position based on a particular skill set and physical attribute. So, see how well this compares to your 5-number summary that you did for the first assignment. Okay, your homework for this section is to use the first 12 Bronco heights. I've converted them to inches. You'll need to find the mean. You'll need to finish the rest of the chart to find the variance and the standard deviation. Once you've found the standard deviation, you need to make an empirical rule graph and put all of these values in whatever bucket that applies and determine how good does it compare to the empirical rule, just like my previous example. So you probably ought to pause the video now and do this. Remember, it's also downloadable off the site.